So in this lecture, we are continuing the how to find the moment of inertia, right? So I think you remember the moment of inertia of many objects I told you yesterday, right? The two more objects, suppose this is the hollow sphere, right? This is the hollow sphere, although we can find the moment of inertia of this, but right now I'm just giving you the formula. What is the hollow sphere about the diameter? X is about the diameter. Can you tell me what is the hollow sphere? Similar to the football, right? Like football. What is the moment of inertia? It is a 2 by 3 mr square. All right. And the solid sphere, this is the solid sphere. What is the moment of inertia about the diameter? Hollow sphere about the diameter, or you can also say this is the symmetric axis. The moment of inertia is 2 by 5 mr square. You have to remember this moment of inertia of the hollow sphere and the solid sphere. Although we can find, and we will find right later, how to solve this moment of inertia like this. Can you, yes, do you understand this? Also, again, this is the axis of rotation passing through its center of mass, as we did yesterday. If you just cut half, right, if this is the hollow sphere, the hemisphere, right, like this, and this is the axis of rotation, hemisphere, the mass m and the radius r, the moment of inertia will not change. It is again 2 by 3 mr square. Is it clear? And if you consider the solid hemisphere, right, solid hemisphere, and this is the moment of inertia is 2 by 5 mr square. The mass of this solid hemisphere is the mass is m, the radius r. Even, right, if it is the 1/4, right, it is the 1/4 like this. This is the 1/4 of the hemisphere, right? Even it will maybe the 1 part, the mass m, radius r, the moment of inertia does not change, 2 by 5 mr square, right? Copy this. So this is the moment of inertia you have to remember. Now you can write theorem of perpendicular axis, right? Theorem is perpendicular axis. First of all, the important thing is valid for 2D bodies. This is valid for 2D bodies. 2D bodies mean like a rectangular lamina, like a ring, like a disc. Not valid for the spherical body, the 3D object, like a sphere, like hollow sphere, something like that. Do you understand this thing or not? The planar body. Suppose this is the planar body like this, right? This is the body, and we have to assume, suppose in this plane there is a x-axis, and about x-axis if we rotate like this, right, so the moment of inertia is ix. If we choose another x-axis which is perpendicular and in the plane, right, suppose this is the another axis which is the y-axis, right, and the moment of inertia is iy. About this moment of inertia is what? Iy. And then if we choose, this is the another axis which is perpendicular to the plane of the planar body, and this is the, suppose, the z axis, and the moment of inertia is iz. Are you getting or not? Right. So what is the relation between, according to theorem of parallel axis, the ix plus iy is equal to iz? You have to remember. Although there is a derivation, we can skip that. We can do it later. Right. Just you have to remember the ix plus iy plus iz. What is the ix? Is the moment of inertia about x-axis. Right. It is moment of inertia about x-axis. This is the moment of inertia about y-axis. In the similar way, this is moment of inertia about z-axis. I am explaining this. Suppose this is the planar body. Right, like this. So if you assume this is the y-axis, suppose this is the y-axis moment of inertia, right? And if you choose this is the x-axis like this, if this is the x-axis, the moment of inertia about this axis is ix. If you choose this is the y-axis, the moment of inertia about the y-axis like this, and if you choose, this is the z-axis, right? Z-axis, and the moment of inertia about this z-axis you have to find. If you know the x-axis moment of inertia, the axis, this is the x-axis, about this it is rotating like this. If you choose, this is the y-axis, the moment of inertia about this axis is what? This is the axis like this. So then we can write the moment of inertia about z-axis. Iz is equal to Ix plus Iy. This is called the theorem of perpendicular. Please copy this. You can do some questions based on the theorem of perpendicular axis. For example, if you consider this the disk, right? This is the disk. So I think you know the moment of inertia about this symmetric axis. What is the moment of inertia? Say half mr square. Are you getting or not? Half mr square mean it is rotating in this way, right? In this way. Now, if you want to rotate this disk about the one of the diameter, then what will be the moment of inertia? Can you tell me? Suppose this is the disk, this is the disk, and if this is the disk, this is the axis of rotation about this axis of rotation. The moment of inertia is what? Say half mr square. Now you want to rotate this disk about the one of its diameter. This is the axis of rotation, diameter. About this you have to find the moment of inertia. Do you understand this or not? Right, it is very necessary to understand the axis of rotation, right? So this is the moment of inertia you have to find about one of its diameter, right? So listen one thing, this is the side view. Okay, if this is the x-axis, right, so I choose another axis which is just perpendicular to this, and this is the y-axis, and I choose this is the z-axis. Are you getting or not? So if you are choosing about this diameter, the moment of inertia is Ix. If this is the axis of rotation, right? Listen one thing. If this is the disk, this is the x-axis, you are rotating like this, right? This is the x-axis. Now, if you choose a perpendicular axis, now the moment of inertia about this axis will be what? Say Iy, right? This is what? Say Iy. And about this axis, Iz, we know the Iz. Do you know the Iz? Yes, it is half mr square. This is the side view. I will try to draw this top view, right? If you look from the top, so from the top, it will be seen like this. You are watching this like this. If this is the axis of rotation, it is rotating like this, right? If this is the axis of rotation, this is the rotating about this axis. So this is the x-axis, suppose this is the y-axis. So where will be the z-axis? It is the z-axis. It is the z-axis like this. So what is the moment of inertia about x-axis? Suppose Ix, suppose Iy, and the moment of inertia about Iz-axis. So is it planar body? We can apply the theorem of perpendicular. And what is that? Say Ix plus Iy is equal to Iz. Is it clear or not? So what is the moment of inertia about z-axis? Say half mr square. And since this is the diameter and this is also the diameter, so the Ix and Iy will be the same. So Ix and Iy both are same. So 2i is equal to 1 by 2 mr square. So the moment of inertia is 1 by 4 mr square about diameter. About diameter. Do you understand or not? So you will remember this. Copy this. For disk of mass m, radius r, we are trying to find. Copy this. So okay, so can you remember this? What is the moment of inertia of the disk about the symmetric axis, and the axis is perpendicular to the, this is the axis perpendicular to the plane of the disk. What is the moment of inertia? Say by 2. And what is the moment of inertia any of the diameter? Mi square by 4, right? In the same way, can you find for the ring? For the ring of mass m, radius r. If this is the ring, right? What is the moment of inertia about this symmetric axis, which is passing through its center of mass and perpendicular to the plane. The moment of inertia is, tell, say mr square. Did you remember this? Yes. Can you find the moment of inertia about one of its diameter? Yes. In the same way, we can find this is the x-axis, y-axis, and assume this is the z-axis. So definitely it is the iz. What is the iz? Mr square. And this is the ix, and this is the iy. Are you getting this thing or not? So if you apply the theorem of perpendicular axis, what is that? Ix plus iy is equal to what? Iz. What is the iz? Mr square. Ix and iy both must be symmetric, both must be the same, and because they are symmetric. So I plus I, 2i is equal to what? Mr square by 2. So the moment of inertia about one of its diameter is what? Say half mr square for the ring. Do you understand this? Copy this. So for the disk and the ring, you will remember all this moment of inertia, right? For example, if you consider the plane rectangular lamina, did you remember? Yesterday I told you this rectangular lamina is like a rod, right? If this is the side A, if you revolve, if you rotate about this axis, can you tell me what is the moment of inertia if the mass of the side is A? Can you tell me what is the moment of inertia about this axis? Very good, ma square by 3. And what about this axis? Yes, 12. Very nice. Right. And if this is the side B, what is the moment of inertia about this axis? mb square by 12. Right. So, can you tell me if this is the rectangular slab or the lamina, this is the side A, this is the side B. If this is the axis of rotation mean, right, this is the axis of rotation, mean the moment of inertia about this axis you have to find. I think you can do this or not, right? What does it mean? Okay, listen one thing. If this is the rectangular lamina like this, so moment of inertia about this axis is what? Say mb square by 12. Is it clear or not? And about this axis, the mb square by ma square by 12 it is, right? Now, if the axis of rotation is this is the axis of rotation perpendicular to the plane and passing through its center of mass. So you have to find the moment of inertia, right? So I will assume this is the x-axis. So what is the moment of inertia about the x-axis is what? ma square by 12. I assume this is the y-axis. The moment of inertia about y-axis mb square by 12. This iz you have to find. Are you getting or not? What does it mean? This is the side view, and this is the top view. So if I assume this is the x-axis, the y-axis, so about this axis, this is the ix is equal to ma square by 12, I think, and about this axis, this is the iy is equal to mb square by 12. About this axis, you have to find. This is the axis of rotation and it is rotating like this. So iz is equal to what? Say ix plus iy is equal to ma square by 12 plus mb square by 12. Do you understand this thing or not, you tell? Right. The special case for the square, for square the side A and B are equal, right? So for the square, what is the moment of inertia about this axis? If it is A, this is also equal to the A, right? About this axis, you assume it is the Z axis. So if A and B are equal, so ma square by 12 plus ma square by 12, the answer is ma square by 6 is the moment of inertia for square. This is the moment of inertia passing through. This is the moment of inertia passing through center of mass, and axis is perpendicular to the plane of square, plane of square lamina, you can say. Do you understand this? Copy. So this is the case. You can find the moment of inertia about an axis passing through the center of mass perpendicular to the plane. But if this is the lamina, suppose, right, this is the rectangular lamina of the size A, of the side B it is, right, the mass is m, right. Okay, if it is rotate about this axis, this is the axis, can you find the moment of inertia? Right, what is the axis of rotation? This is the body, and the axis is passing through this axis, right, and it is rotating about this axis. Do you understand the concept? Yes. How to find? I will give you 1 minute to think about this. The perpendicular axis theorem we can apply. Very nice, very nice. Okay, so how to solve this? Suppose we have to find this. Assume this is the x-axis. Assume this is the y-axis, right? Y-axis. So if you rotate about this axis, what is the moment of inertia? Say mb square by 3. Is it clear or not, you tell? And if you rotate about this axis, so what is the moment of inertia Iy? Say ma square by 3 it is. Now the Iz you have to find. So what is the moment theorem of perpendicular axis theorem? Iz is equal to Ix plus Iy is equal to what? Mb square by 3 plus ma square by 3. Right, the masses are same. So 1 upon 3 ma square plus b square. If this is square for square, the side A and B both are equal. So Iz is equal to what? 1 by 3 m a square plus a square is equal to 2ma square by 3. This is the answer. Copy this form. So this is the square, and for the square, this is the moment of inertia, right? If this is the square, suppose for square, I'm considering the square only. If for the square, can you find the side A, and this is the side A also? Can you find the moment of inertia about this axis? Right, what does it mean? You may consider this is the square, although it is rectangular, the square mean about one of its diagonal, it is rotating like this, so you have to find the moment of inertia, right? I will give you 1 minute to think about this, how to solve. Copy this. How to solve this? Listen, listen one thing. If this is the, I choose this is the x-axis, I'm making here again. If I choose this is the x-axis and I choose this is the y-axis, so for the square these are perpendicular. Are you getting or not? So about moment of inertia about x-axis is Ix and about y-axis is Iy. Can you tell me what is the relation between x and Ix and Iy? You tell. They are equal. And suppose this is the z-axis, right? Z-axis. Do you know the moment of inertia z-axis? What is that? Ma square by 6, right? Ma square by 6, that is fine. Ma square by 6, right? Ma square by 12 plus ma square by 12 is equal to ma square by 6. So what is the theorem of perpendicular axis theorem? Theorem of perpendicular axis is Iz is equal to Ix plus Iy. And what is the x and y? They are same. And what is the Iz? Say ma square by 6 is equal to 2i. So what is the moment of inertia about this axis? Say ma square by 12. Are you getting or not? Ma square by 12. Copy this. Listen, one very important question. Suppose this is the square, this is the moment of inertia about one of the diagonal. You may write moment of inertia about the diagonal of the square, right? So this is the thing. Now if you consider the another question, suppose we have this is the square, right? This is the square, you may write square of mass m, the side is a, and this axis is passing through the diagonal, but I am considering an axis which is passing like this at angle theta. Can you find the moment of inertia about this axis? An axis not passing through the diagonal, right? not perpendicular to the length side of the square, rather at an angle theta. Theta way they may give the 60 degree or the 30 degree. So can you find this moment of inertia? Please try this, copy this. So we can solve this question. How to solve this question? Listen one thing. Suppose this is the theta. This is the, can I choose this is the x-axis? Right, I can choose the x-axis. Can I choose another axis which is just perpendicular to this? Just perpendicular to this. So if this is the axis making angle theta, so this is theta, this is theta. So if I choose this is the y axis, so can you think these axes are symmetric or not, you tell? The moment of inertia about the x-axis and the moment of inertia about the y-axis, what is the relation you can find? You tell. You tell. What is the relation? If this is the theta, this is the axis, and this is the another axis, right? Are these axes are similar or not? You tell. Tell me. They are perpendicular. Getting or not? Suppose these are the, this is the square, right? If this is the one axis, this is the another axis. So if I rotate by angle theta like this, right? By angle, this is the axis. If I rotate by some angle like this, right, like this. Are you getting? Not getting. If these are the axes, if I give some displacement, right, so these axes are similar, you must say. Suppose this is the square. If you rotate this axis by angle theta, suppose, right, theta, so this angle is also rotated by angle theta. Are you getting or not? So if the moment of inertia about this axis is I, what is the moment of inertia about this axis? Must be I. This is the square plate. So if you just give some displacement, angular displacement theta, so this axis is also, because these two axes are perpendicular. So if the moment of inertia about this is I, so moment of inertia about this axis will be the I dash I dash. Do you understand or not? Right? So if you give more angular displacement, so it will come this side. So whatever the angle theta is, you choose a perpendicular axis to this given axis. So if this is the x-axis, this is the y-axis, both axes are perpendicular and both moment of inertia must be equal to same. Do you understand this thing or not?
Yes, sir.
Should I explain once again, right?
No, sir.
Right. Okay. Then it's fine. So if this is the x-axis, this is the y-axis, what is this? This is the z-axis. So theorem of perpendicular axis is what? Say Iz is equal to Ix plus Iy. And can you tell me what is the moment of inertia about z-axis of the square? Ma square by 6. So this is ma square by 6 is equal to I plus I. So what is the moment of inertia? Ma square by 12. Do you understand this thing or not? Right. So what the conclusion you may draw? Listen one thing. If this is the axis of rotation for the square, what is the moment of inertia about this axis? Say ma square by 12, right? And if you tilt this axis by some angle, suppose this is the square, right? This is the same square, right? If what is the moment of inertia about this axis passing through the center of mass? Tell me. I is equal to ma square by 12 again. Are you getting or not? At any angle, it may be the alpha, it may be the theta. If you choose any axis in the plane of the square, any plane, any axis, suppose you can consider this the axis, right? You can choose any axis. This is the axis, this is the axis, any axis passing through the center of mass of the system. The moment of inertia is what? Say ma square by 12. How? Because if we choose a one another axis which is perpendicular to this, so both moment of inertia will be the same by symmetry, and you will apply the perpendicular axis theorem, and ma square by 12 you will get, right? Copy this. Listen one thing. This thing is valid only for square. If we consider the rectangle sheet, from here you can write, right? If this is the rectangular sheet like this, A and this is the B, are you getting or not? If I ask the moment of inertia about this axis, the moment of inertia you have to find about this axis, right? So can you tell me, think about this, how to find the moment of inertia about the diameter? Copy this. Yes. Can you tell me what is the moment of inertia about the diameter, about the diagonal?
That is a square by 24 plus b square.
Right. Okay, you have given the answer, but the thing is that, listen, the it is the calculation is very tough. I will do it later, but I want to tell you, if you consider this is the diagonal like this, so these diagonals are not at 90 degree. So if you choose this the x-axis, it is not the y-axis, and this angle is not 90 degree, right? It is not 90 degree. So here in the same way what we have done for the square, we cannot apply the perpendicular axis theorem. We have to find the moment of inertia about this diagonal, and we will do it later, right? We will do it later, because today I want to teach you the theorem of parallel axis. We can do this question later, okay beta? But it is not like that ix plus iy is equal to iz. It is not like that. Do you understand this thing or not, you tell?
Yes, sir.
We cannot apply the perpendicular for the square only. We can apply the perpendicular axis theorem, because this is 90 degree. If it is ix, it is iy. That is the reason of what all the calculation, whether it is for the square we have done, not for the rectangular lamina. I will solve this later, but now I start the theorem of parallel axis, right? You may write theorem of parallel axis. What is the theorem of parallel axis? In case of perpendicular axis theorem, this is the two-dimension body, right? It is valid for two-dimension body, but this is valid for all types of bodies, right? All types of bodies. All types of mean all types, whether it is 2D, 1D or linear body, right? What is the theorem of perpendicular axis, parallel axis theorem? Suppose this is the body and this is the center of mass of the body, right? This is the center of mass of this whole body, and axis passing through the center of mass, right? If you rotate about this axis which is passing through the center of mass, the moment of inertia is ICM. Now if I consider another axis, right, AA dash, which is parallel to the this axis, right, and the perpendicular distance between them is what? CD. So this is the moment of inertia I dash. I can write according to theorem of parallel axis is equal to ICM plus m into d square. What is m? M is the mass of the body. Although there is a derivation of this, but right now I'm telling you the only the theorem, and with the help of this theorem we can solve this question. Proof we will do it later. Please copy this. So what is the ICM? You can write where. What is the ICM? ICM is the moment of inertia about an axis, passing through center of mass, and d is the perpendicular distance, perpendicular distance between two axes, right? M is the mass of the body, mass of body. Yes, copy this. And then this is the moment of inertia. So we can do some questions based on the theorem of parallel axis. For example, if you consider the rod, this is the linear object. Do you know what is the moment of inertia of the rod about this axis? Say ml square by 12. About this axis, what is the moment of inertia? Say ml square by 3. Did you remember this thing or not? Yes, this is the center of mass. Listen one thing. If I assume this is the center of mass and I want to find the moment of inertia about this axis passing through one end. This is the axis passing through the one end, right? So how to find? Apply the ICM. Although I know, but I am verifying this. So this is the center of mass axis, ICM. And what is the distance between them? Distance between them is L by 2, right? The distance between them is d is equal to what? Say L by 2. Is it fine? So what is the IAA dash is equal to ICM plus M into d square. What is the ICM? ML square by 12 plus M. What is the d? Say L by 2 whole square. ML square by 12 plus ML square by 4. When you will take the LCM, the 12 is the LCM, ML square plus 3ML square. So this is 4 ml square by 12. So answer is ml square by 3. Is it clear or not? Listen one more thing. If this is the axis passing through the axis IAA dash, passing through one end, axis passing through one end, passing through one end. All right. Suppose this is the another example for the same rod. Suppose this is the rod, right? And this is the axis, and this is L by 3 over here, right? This distance is L by 3. This is the axis A dash. This is the rod of mass M, length L. This is the center of mass. You have to find the moment of inertia IAA dash. And this distance is given as the L by 3, right? Copy this. So what is this? This is the moment of inertia of the disk about an axis, which is passing through the center of mass, passing through the circumference, and this axis is perpendicular to the plane of the disk. So I is equal to ICM plus MD square. So what is the ICM? Say MR square by 2, and what is the D? Say D. So MR square, 3 by 2 MR square. Now if this is the disk, right, and the axis is passing through the circumference, again this axis passing through the circumference, but it is in the plane of the disk. This is the axis I, this is the A dash. You have to find IAA dash, right? Do you understand this thing? This axis passing through the circumference and it is in the plane of the disk. A dash, axis A dash, passing through circumference, and in the plane of the disk, plane of disk. This is the question, right? This is the axis passing through the circumference and perpendicular to the plane of the disk. So can you find this answer? Yes, we can find. How to do that? Listen one thing. You can make the figure, right? The top view, center of mass. This is the axis. About this axis, the disk is being rotated. Do you understand this thing or not? Right. So what is the center of mass? Moment of inertia about the diameter. Did you remember? What is the moment of inertia about the diameter of the disk? MR square by MR square by mr square by 4. This is the moment of inertia about the diameter, right? About the diameter, and this is the diameter passing through the plane. So this is the moment of inertia about the axis passing through the center of mass and perpendicular to the plane, mr square by 2. So did you remember or forget? You have to remember. So what is the moment of inertia about this axis? IAA dash. So what is the perpendicular distance? Say D is equal to R. So I will write here the IAA dash is equal to what? Say ICM plus M into D square. What is the moment of inertia? Say mr square by 4 plus M into R square. What is the answer? 5 by 4 mr square. Did you understand this thing, Varsha, or should I explain once again? Should I explain this, Varsha? Right. Copy this. Copy this. See this question. Suppose this is the block, right? And this is the block initially in equilibrium. The mass of this block is what? Say 0.1 kg, right? 0.1 kg. When it is compressed to some distance, right? So if it is compressed to this distance, the x distance, and now it is released. When it is released, so from after approaching the half distance from the equilibrium position, yes, when it comes to over here, this is the x by 2, this is x by 2. It hits the another block and come to rest momentarily. So this is the, suppose this is the mass m. When it hits, it will have some velocity v, right? So when it hits and other block start moving, after hitting the block, it come to the rest and the other block start moving with speed v, right? Here it is the block and start moving with speed v. It come to the rest. So what does it mean? And the speed is 3 meter per second. So what they are asking, total initial energy of the spring they are asking. I think it is not mentioned in the question that the collision is elastic or something else. So if I assume the collision is elastic and the mass is same, so it may be only possible because it is at rest and the another block is moving with the some same velocity. Hit another block and come to rest momentarily. A block is connected to the unknown spring constant K. So the total initial energy of the block they are asking. So the mass of the block will be 0.1. So its kinetic energy of the block will be half mv square. And here the spring kinetic at this point, this is the point A, this is the point B. At point A, what is the kinetic energy? What is the spring potential energy? Half kx square. At this point, the kinetic energy is, the potential energy is half k x by 2 square plus kinetic energy is half mv square. Is it clear or not? This is the kinetic energy plus potential energy at A point, kinetic energy plus potential energy at B point. This is the point A, this is the point B. Before collision, I am talking. So all the potential energy of the spring is converted into half k x by 2 square plus half mv square. Listen one thing. If it come to rest, the collision elastic I am assuming, so the mass will be the same and the velocity is interchange. So its kinetic energy of the block before collision will be same as that of the kinetic energy of this block. So half m v square is equal to half, the mass will be 0.1 and the v square is 3 square. So 0.9 by 2, 0.45 joule is the kinetic energy. And this is equal to 1 by 4, 1 upon 2 kx square plus its kinetic energy is 0.45 joule. So when you will simplify this, right, half kx square 1 minus 1 by 4, right? This is the half kx square, and 1 minus 1 by 4 is equal to 0.45. So half kx square is the initial kinetic energy, initial potential energy, 3 by 4.45. So half kx square will be equal to what? 4 multiplied by 0.45 upon 3. 4 into 15 choka 60. 0.6 joule should be the correct answer. Right. Copy this. For this question, what is the mass of the hydrogen? The m of 3.32 into 10 ki power minus 27 kg. And 10 ki power 23 dn upon dt is equal to what? 10 ki power 23 molecules are there. Striking the area, right? This is the wall area, 45 to the normal like this. So the molecules are coming, right, continuously, and they are striking at the 45. This is also 45, this is also 45. And suppose this is the area, and they are rebound elastically. It is told they bound elastically mean their velocity will be, if it is u v, definitely it will be u with the speed 10 ki power 3 meter per second. It means this speed will be also 10 raised to a 10 raised to 3 meter per second. Is it clear or not? So what they're asking to find the pressure. To find the pressure, we have to find the force, right? Force. Listen one thing. To this, so to solve this question, you may remember or you may consider a concept, right? Concept you may write. It will help you always. If suppose this is the wall, right? This is the wall, and there is a gun, right? And from the gun, the bullets are coming from the gun, and they are hitting this, right? Or you may consider there is a pipe, and the water is striking the wall, right? So what, the water come to rest after hitting, or it may rebound. So that is the different thing. So you, when the pipe or this bullet, right, this gun fire the bullet, so it will exert the force on the wall. So that force you have to find. The force is nothing but rate change of momentum, dp upon dt, right? Because if you consider this the m, if you consider the dm mass and moving with speed v, so the momentum is change, right? One more thing, if you consider this is the m into v, and it is coming, it is, suppose it is rebound elastically and with the same mass, right? It's with the same velocity it is coming. So can you tell me what is the change in momentum in this case? In this case, the momentum changes this 2mv. Are you getting or not? This is the momentum change. So what is the change in momentum of a one bullet? What is the change in momentum of one bullet? This is 2mv. So for n bullet, what is the change in momentum you tell? N into 2mv. So it is equal to 2mv into dn upon dt. So what is the force applied? This is the force applied on the wall. You will remember what is the force applied? Change in momentum multiplied by number of bullet striking per second. Are you getting? This is the change in momentum. This is what change in momentum multiplied by number of bullet hits per second. Is it clear or not? So it is happening in this case also. But sometimes they give the pipe and the water is moving with the speed v. And suppose after that, after striking the wall, water come to rest. Water comes to rest, right? So water come to rest. So if you consider the dm mass, Suppose this is the dm mass. Dm mass is moving with the speed v and it strike and come to rest, right? So before collision, what is the momentum? Say dm into v. After collision, when it come to rest, what is the change? What is the momentum? Say 0. So what is the change in momentum? The change in momentum is equal to dm into v. Are you getting or not? Varsha, hello, please speak. When it hits right and come to rest, the change in momentum. This in this question also they can give that the water rebound with the speed v. Then what will be the change in momentum? Say 2 dm into v. But I am writing here in generally it come to the rest, right? So this is the change in momentum. So what is the applied force? The applied force is what? A rate change of momentum. Are you getting or not? So the momentum changes dm into v. V is the what? Speed upon dt. Are you getting or not? What is the dm? Dm is the small mass, elemental mass. Dm is equal to what? Volume dv into density. What is the volume? Say area. What is the area of this drop is A into dx into rho. So this is the dm mass. So in the dm mass, I will write A dx into rho upon dt into speed v. So this is A into rho dx upon dt into v. All right. What is the dx upon dt? The speed is nothing but say dx upon dt. Are you getting or not? This is the thing. So I can write down the force applied on the wall due to the stream of the water is A rho V into V square. This is the force. And if you want to find the pressure, force upon area is the pressure. Are you getting or not? You tell. Right. So the force will be found by dp upon dt formula. Now we come to this. First copy this, then we can do this. So in this case, can you tell me what is the change in momentum? If this is 45, this is the v, it is 45. This is the v cos 45, and the collision is elastic, therefore it is 45. This is the v cos 45. So only the change in momentum. Suppose this is the mv cos 45. Now this is the mv cos 45. This is the velocity or the momentum which remains same. So can you tell me what is the change in momentum in this case? Say 2mv cos 45, right? Or u 2mv cos theta. So mv into root 2 is the change in momentum. So what is the force? What is the force applied on it? Force applied, change in momentum per unit time, dp upon dt. So m into v root 2 upon dt upon dt. Listen one thing. This is the change in the momentum of one ball, but according to question, right, the n is equal to dn upon dt is given, mean you have to multiply for, listen one thing, if you think like this, d upon dt, so this is the change in momentum of one ball. If n ball strikes, what is the total change in momentum? Say multiply by n. Are you getting? This is multiply by n. So d upon dt, n into mv root 2, right? So mv root 2 will come out from the integration and it become dn upon dt, right? So you have to remember this thing, this type of the thing. So this is the dn upon dt, number of bullet hit per second multiply by change in momentum. In this case, the change in momentum was say 2mv. In this case, the change in momentum is 2mv cos theta multiply by dn upon dt. This is the force. So what is the pressure? Say force upon area. So mv root 2 dn upon dt upon area is A. So what is the mass? The mass is 3.32 into 10 to the power minus 27 with the speed. What is the speed? 10 to the power 3, I think. It is root 2. And number of bullet per second, number of hydrogen mass per second is what? How many? 10 to the power 23, right? Divided by area. What is the area? 2 into 10 to the power minus 4. So if you solve this, then you will get the answer. So this is the pressure, 3.32 into root 2 upon 2 into this is what 1 into 10 की power 3 it is. So this is 1.6.6. तो 1.66 into root 2 1.41 166 6 चौक 24 और 2 26 6 कम 6 और 661 6 जीरो यहाँ से लग गया 1 6 दूनी 12 और 2 14 6 दूनी 12 13 यहाँ से लग गया 2 2.34 into 10 की power 3, right? So this is the pressure in Newton per meter square. So first option is the correct option. Copy this.